So good morning, everyone. It's my pleasure to welcome you all for our roundtable event named Harvesting Synergies, Innovation at Water Energy Nexus. I'm very happy to moderate this roundtable, and I'd like to start by thanking each of you, especially who traveled some distance to join us in Malta. So this is the first event of our event series in Malta of our COST Action PEN Hydropower. So we are working group number 2, Pavel and Rudolf, who is online, and me, Doğan Gezer, are leading working group 2. The name of our working group is Technological Evolution through Innovation and Digitalization. This roundtable is a part of our ongoing work, and we bring together from across research, public and industry, public institutions and industry. And that's what we want, because we don't want just only experts from a single expertise to be together, but we like to have people, a mix of people having different perspectives and experiences. So we all concentrate on the question: how can we unlock the synergies between water and energy systems through innovation? So, as you all know, water and energy are highly interconnected. Energy sector needs water for energy generation, for instance, for hydropower or for cooling in thermal power plants, even for green hydrogen generation. And water sector needs energy for moving or treatment or delivery of water. So if we consider sustainable infrastructure, we cannot separate the two. Today, we will concentrate on three particularly important areas. First is the hydropower applications. So we'll try to rethink hydropower applications in traditional hydropower and integrate hydropower into non-traditional environments like drinking water systems. Second sector is the energy recovery technologies. So we'll try to find energy potential, especially in infrastructures like water systems. And the third one is the water distribution systems themselves. So water distribution system or drinking water systems are becoming sites for improving energy efficiency and local generation. So through digital smart solutions. The goal of today's discussion will be go deeper, and we'll try to we want to understand what enables innovation to actually reach implementation, how to reach implementation from innovation. So what barriers we have and what is working on practice. Also, how can we collaborate between sectors, public, private, and academic, to bring ideas into impacts. And we will be hearing real-world applications, emerging technologies, and also lessons learned from past projects and ideas for where to go next. I encourage all of you to be open during the discussion and eager to share your success stories and also challenges, because that's the only way we can exchange our experiences, so we can learn. And also, we keep this roundtable intentionally informal, because this is not a lecture series. This is a dialogue. So this is a dialogue between the speakers and the session, and between the session and the audience. So please do not hesitate to jump in when the floor is open for discussion and your opinions. So I want to thank you again for being here, and let's make this roundtable a productive, inspiring discussion. So let's start with intro. Let me introduce or invite our speakers first. So first, I want to invite George Agidis and George. Thank you there. And our second speaker is Miroslav Petrinic. Hello, everyone. So, and our last speaker is Miroslav Marens. So, please take a seat, Miroslav. Before I give floor to them to introduce themselves, I will introduce myself first. So I'm Doğan Gezer, I'm leading working group 2, and I'm attending this roundtable from Turkey, and I'm the head of division of energy technologies of a public research center. Our research groups are concentrated on electrical power research with renewable energy technologies, power electronics, energy forecasting and monitoring, and also power systems analysis. Thank you for being here. And let's start with George. George, could you introduce yourself?
Yes. So, do I press the button at the bottom or?
There's a button here.
Oh, this one looks working. This is working. Good morning, everybody. Nice to meet you in 3D now. I've seen you a few times in 2D so far. Giovanna, I can see you right at the end back there. Yes, I'm Professor George Agidis from Lancaster University in the UK, and the country member from the UK. And should I say a few words about myself, or what do you? Okay. And since I was very young, I was born in Thessaloniki in Greece. I'm Greek. I always wanted to be involved, fascinated for waterfalls in Edessa. Perhaps you've been there. And I always want to become involved with water and power. I ended up in the States as a teenager for school, and picked up a book from the library of my school in the States. Industrial Revolution started in England. And the oldest training school for professional engineers in the world is in the city of Manchester, and a company called Mother and Platt. Probably at the time the largest fluid machinery manufacturer in Europe or the world, maybe. I got on a plane from United States, went to Manchester, and I joined Mother and Platt, and that's where my engineering career started as a teenager. Involved with design of fluid machinery. And then my last position in industry was director of the largest turbine manufacturer in the UK. I still do that job with my PhD students, but now with the position I have, I'm also involved with other areas that involved fluid machinery and water, and including energy, not only from hydropower onshore, involved with hydropower offshore, and marine energy, ocean energy, and novel ideas around water and hydropower. Thank you.
Thank you, George. Now you can continue, Miroslav.
Okay. Also, I like to welcome everybody that came here. I'm Miroslav Petrinic. I come from Končar, Croatia, from the institute part of the Končar, where we develop certain electrical devices. And my field of expertise are rotating electrical machines, mainly hydro generators. Company has been building them for over 100 years now. And we are, of course, trying to improve this and increase the value of these kinds of machines and try to do the best we can there. From my standpoint, I've been there for 18 years, and I think that the situation is interesting, to say the least. There are certain aspects that are struggling, but also there are some opportunities to improve things. And I really hope that these things can be basically expressed through this cost action and given a broader information to people so that things are not that bad.
Thank you. Thank you, Miroslav. And Miroslav, please.
Yes, I'm also Miroslav Marenche, and I'm also from Zagreb originally, but living for more than 30 years in Austria and working as a consultant in Africa, in Salzburg, where we design mostly the pump storage power plants. I'm civil engineer from origin, and yes, we are working 95% in hydropower, or from this 95% in pump storage in the last 15 years. And for nearly 20 years now, I'm a professor on IG Delft and also a guest professor on TU Delft in Netherlands. And here I'm as a Netherlands, but born in Croatia, living in Austria and partly working in Netherlands. You can say fully European as a philosophy of this group. Yes, my expertise are mostly in civil engineering for the hydropower, mostly tunnels and the underground works. Where in the pump storage is very big development in last 15 years, we can say, and interest from IG as a biggest water faculty on the world, because we work only with all types of problems or research in case of water. We are working a lot on the small hydro, on sustainable hydro, and say hidden hydro, which Logan also said. And on this way, it will be interesting to have all these discussions. Thank you.
Thank you, Miroslav. While you have the microphone, let's start with you. Okay.
Okay.
Thank you. Thank you. So, all of us here, we are trying to enhance the water energy nexus. So, what recent innovations or emerging technologies do you consider the most promising in your area?
I can say we on IG Delft see this water energy nexus a little bit wider, because we are connected everything with water, and then we call this nexus water energy food and ecosystems nexus. And this is the way, I must say, before 15 or 18 years, when I was just a civil designer, then for me all other users were the problems. They want to reduce my power and my energy production, and they are making problems. We can say in this easiest way. After that, when I came to IG, I spoke with a lot of colleagues which are working on other works, and then I got my wider look on the world. Let's say from civil technical straight look. I have now the wider look on it, and I see the importance of others. And this is, I think, something which will be the future in we can say sustainable hydropower or sustainable world, that we have to share our water resource. This is a big challenge. I will not say problem, challenge for us in all world around the world. For example, I'm living in Salzburg, and you will say it's a green country, a lot of lakes, a lot of snow, a lot of glaciers which are melting. We think we have no problem. We cannot have a problem with the water. When I spoke with my friends, they said we will never have a problem. Last summer, we had a serious problem around the Salzburg because not only that the groundwater level dropped down, it dropped down because there is an industry, cheese industry mostly, which is pumping water from the underground, and the problems started. The winter was also not very good from rainfall and snow especially. And the result was that a lot of the underground water pumps, not water pumps, the heating pumps. I don't know how it is called in English. When you heating pumps from underground, not the air ones, from underground were in the air because the groundwater level dropped down and there was no possibility for pumping. And you see the problems on the place where you are not expecting any problems at all. And because of that, we must be very careful.
Thank you. All right. Do you have any implementation or example of any innovative approach for civil engineering?
What
latest advancements?
What we are doing, what we are working on is in the small hydro, low head hydro, especially interesting for Netherlands because it's a very flat country. We are working with different companies which are developing low head turbines. This means the turbines which have head from 1.5 to 3 to 5 meters, we can say, where we have good examples. This is also my appeal always to the hydropower. Don't be used for efficiency of 90%. We can also very good work with the 70%. It's also good efficiency compared to all other machines or other energy sources what we have. We are still on very high range. Of course, it's not 90, but for low head, also the other turbines, classical turbines, are not working. This is one place. We are working also on the pump storage, small pump storage, with or without salt water. This goes for the islands, isolated islands, or for example, we have a research solution for North Sea pump storage system with a big lake built with a ring dam in the North Sea, and several systems also working on the water supply systems to take the water supply system. This works. For example, this I found out in Netherlands that these water supply systems are not working at all because the law is that you should use all pumped water energy pumped up in the water towers. You must use for distributing network. It's not allowed to take the energy out. But if you are in the Alpine regions where you have towns in the hills, this could be a good example. For example, EPLF made a study several years ago where they for the town Fribourg, for example, found out that nearly 60% of energy can be recovered, which was used for pumping.
Thank you, Miroslav. Especially here, 1.5 meter low head turbines is very interesting. Thank you so much. So Miroslav, I know you're very experienced in synchronous machines and generating electricity. And what are the innovations in your side?
Okay, I will speak also a little bit broader this time. And I don't think that Miroslav will like what I have to say, but I will give you a perspective. I will try to give you a perspective of what is happening and how we see the industry. So we are manufacturers of certain part of the hydroelectric power plants. We don't build turbines, we don't build construction works. We are part of it. And we always look at the ratio between elements, what costs how much. And the problem that we are facing mainly is that construction works are very expensive. They have exploded actually. And there are several reasons why this is so. Some things are happening for decades, and some things are happening in the recent years. And I would like to inform you about this because just to give you an example of what is happening. For instance, if you look at the housing, standard housing in 70s and today, ratio between inflation and housing prices have quadrupled. So buying a house or a flat is 4 times expensive for a person related to his income than it was in the 70s. There are certain reasons why this is so. I cannot say why that is or all, but I can give you an last example of how it happened, and it is basically corruption of construction conglomerates because we had an earthquake like 5-6 years ago in my country, and then the European Union decided to give money to help rebuild the houses, flats, etc. And what the construction companies did then, they raised prices threefold. Okay, so something that was costing, let's say, 2 million euros now costed 6 million euros, basically overnight, because it is the money given from European Union, and then that is a practice where you can take money, and that's bad, and it's bad on several levels. I mean, everybody should be pissed off by this, because frankly, money is given by European Union from rich countries, Finland, Germany. You should be pissed off. But this is not just happening in Croatia. This is happening everywhere because regulations are not working properly. And then what does that mean? That means that these construction companies get accustomed to this kind of prices. For instance, somebody who I would like to give a poll, but I don't have time now. But what do you think? What is the price of somebody who drives a crane in Croatia? Net salary monthly. It's 5,000 euros. And that's half is black, because when you look at the average price how people are paid, it's like 1,400, 1,500 euro net. That's like a base price that you will find on the internet, how much people are paid. But these people, and they're not even Croatians, you will find now people from other countries that work on this kind of jobs. They're heavily paid because that's how these markets work. And now let's talk about the innovation. Now these things also affect hydropower plants. Now we built hydropower, one new power plant. It should be finished this year, and we were heavily attacked because of the price and how much it costs. But heavy part of that price is because of the construction works. And then people compare solar to hydro, and there are two things to address there. One is how it is compared. It is compared by the output power, which is wrong because solar power plants never produce output power for which they're produced. They produce half. But secondly, the basic problem is that this price is not leveled down. And when you look at the construction, it is like disaster. And what we see as a major improvement in hydropower is robotic manufacturing. Just last week, I read an article where Chinese have built a skyscraper 28 stories high in just a few days, in less than a week, by using roboticized machinery. There are robotic tools. I know that Miroslav can say these concrete constructions are not as strong and such, blah, blah. And he's true, he's right. But the question is, how strong do you need to have? We now have such situations where building something from metal, let's say crate type of power plant, is cheaper than building from a concrete. That's the situation.
Miroslav, do you see possible to build or manufacture a generator or the stator or the core by robotics or additive manufacturing, for instance, decreasing the cost?
Well, not by additive manufacturing because we need to have laminations, but by roboticizing it, yes. I think that it could be a possibility. There are issues. The reasons why it is not done for generators is because each generator needs to have its own dimensions. It needs to be accustomed to the river and so on, to the dam, to the fall of the water and so on. But generally speaking, new technologies like AI that allow for fast reprogramming, that should allow for fast reprogramming of the manufacturing tools, should in the future allow for these kinds of, let's say, one-off machines to also be done by robotic tools. Not fully, but at some point at least.
Thank you.
Yes, I'll just conclude one more thing because this is not only by power plant but water energy nexus. On the hydro this last year, HIT was a robot that travels on the bottom of the upper lake and then sucks out sediment through the pipe on the other side. And so that's actually also one part of the things where robots could actually help. And I think that that's the future.
Thank you. Thank you for the example also.
Miro, thank you.
Yeah, George.
Same question?
Yeah.
Okay.
Do you mind?
Yeah, of course. Okay, I'll tell you what is happening in the UK now, and specifically with me at Lancaster University. As I said, I have been involved I was director of the largest turbine manufacturer in the UK, so I have hydropower projects all over the world. And we know that hydropower plants live for many years. I still receive telephone calls from places in Latin America and Asia that they have a 75-year-old plant that they need a specific screw to keep it going, which I can easily find the drawings, make it, and they can have it in a week. Surprised that the company is still surviving, alive and kicking. But don't laugh. It's the oldest hydropower manufacturer on the world. It started in 1850 in the UK. Perhaps
I laugh because I know these stories from my former company, from the erection people.
Yeah, and also we might have other companies in Germany that they started in the early 1800s on agricultural machinery, but not on hydropower. They started on hydropower in Germany, perhaps after Mr. Kaplan in 1890s developed his Kaplan turbine, but in England we were manufacturing since 1850s the Vortex turbine, lighting for the first time on the world, the first house anywhere in the world globally with hydropower out of in a house in Newcastle, Lord Armstrong's house. Anyway, fast forward. We have been involved on a lot of novel work in relation to hydropower. Years ago, I was looking into the performance envelopes of turbines, and on the EU website, I saw that the lowest we were going to at the time, it was 5 meters. And I did a global survey to see what manufacturers can declare themselves, and this was true. So, because I'm heavily involved on ocean energy, marine energy, and offshore, we had a request from, I think there is a gentleman from Copenhagen with us here from Denmark. Yeah, where is he?
Ramazan.
Where is he?
He's away for examination.
Okay,
Okay.
okay.
He'll be with us.
They have in Denmark a project called Wave Dragon, and the gentleman developing this wanted an operation of a turbine, a Kaplan turbine. You mentioned earlier Dogan about 2.5 meters, something like that.
Wow.
But
1.5. But the idea
1.5, said
you said, oh, well, I went a bit further than that. Because the application of this gentleman was anything between 1.5 and 0.5 meters head. So we developed a Kaplan to go so low. So this has been, obviously, we had to marinize it and all that, operating in seawater. And we were able to extend the performance envelopes well beyond the 5 meters declared on the UK website down to 0.2 meters head, which means we developed it for an application offshore, but nothing stops us now to have a project in Strasbourg that could be onshore since the technology is already available. So with new applications, innovation begins and new ideas come forward. I had a visit from a gentleman in Florida that for another wave energy application that they developed there, they wanted a very high speed, very small size, high head Pelton turbine. He couldn't find anyone to make it in the United States. He couldn't find anyone to buy it from in Europe. So they pointed the finger at Lancaster University and Professor George Agidis, and I helped him to develop that. He couldn't buy it off the shelf. He had to make it. So again, another application that pushes the frontiers of what we know today. We continuously making new types of turbines. For instance, one of the latest turbines was in England. We invented back in the 1920s. It was the turbo impulse turbine. Do you know about turbo impulse turbines? Yeah, everybody does. Okay. There is a gap between turbo impulse turbines and Pelton turbines, because we can have 90s, mid-90s Pelton turbines, and perhaps turbo impulse turbines operate in mid-80s. Obviously, the problem with Peltons is when the flow splitter erodes with sandblasting, efficiency drops, so we don't have the flat characteristic anymore. This is not existent with turbo impulse turbines. You can sandblast them anywhere, as long as you like, and this efficiency remains. But there is a gap. So at Lancaster University, I still have the test rig available. We developed a novel turbine that fits in between the two, that it has the same benefits design-wise of turbo impulse, so it doesn't lose its efficiency, but at the same time it has much higher efficiency, closer to Pelton. That's another idea as pushing the frontiers. I had a knock on my door from engineers from anybody from Holland here. Yeah, you are from Holland.
Yes.
Yeah, and you. I had a knock on my door from 2 engineers from one of your ministries, and they came to present to me in Lancaster, in the UK, in my office, my research on the River Kent, where I was doing some work on siphonic hydro. Apparently, in the 60s, you had a problem with flooding. You created estuaries, and now the estuaries is causing embarrassment because stagnant waters kill fish, kill plants, kill everything, kill tourism because of smell, and they want to solve this problem with an environmentally friendly engineering solution and erase the embarrassment of the past. They looked into all manufacturers and manufactured products available today that they could kill fish or other environmental problems. And they thought what I was doing in the north of England on the River Kent is their solution. It was siphonic hydro. And they presented my work to me, how it will operate there. So what we were thinking is to, by 2030, to put siphonic hydro, don't destroy the roads you already developed on the banks there. Have a siphonic hydro. You have tides in Holland. So using siphonic hydro with very large pipes, when the water is up, we can pump fresh water in the estuary. And when the water is down, we can pump dirty water out in the ocean when the tide is down. In many cycles, over a long time, with minimum cost. Energy-wise, instead of having a turbine putting energy, we can clean that embarrassment and stop it happening. In parallel, an idea of George Agidis again, on the downstream leg, I let air in, which created aeration. Yeah, on the downstream leg. Aeration is oxygenation and makes the cycle of regeneration even faster. But because you have the pipe going down with air, if you put the turbine at the top, what will happen? An air turbine, what will happen? Like you have a fan in your toilet or in your kitchen, it will start rotating. So as a byproduct, you could easily have some amount of energy to light the lamps in the local area there. So this is another idea that we have used to solve embarrassment from the past, and also this idea doesn't kill fish anyway. It just allows fish to pass through. Another idea, I had a knock on my door from Andritz in Westberg, I think. And they had a project in Indonesia that it was tidal. And the customer there, they wanted some idea like Archimedes screw. Everybody knows Archimedes screw, yeah? That we used to bring water for centuries. Now, over the last 20, 30 years, we can use it for generation, yeah? But also, we can use it for tidal energy. Now, apparently, they found out that the only place on the world, globally, that I still have it, that we have been carrying out research on Archimedes screw, not as tidal stream, in open stream, that it has restrictions from bench limit, but on closed pipe. And with very good results, like a normal turbine. Yeah. So they came to collaborate for a project in Indonesia to actually generate tidal energy. Also, another idea that it's 2017, it's very recent. Again, GE, you know GE, the company, and General Electric, yeah, and Andritz. We were involved on tidal energy. The Swansea Bay Lagoon. You've heard about the Swansea Bay Lagoon project? Anybody? Yes? Anybody? You have heard it.
Yes.
Okay. Sonji Bay Lagoon started in my office from a blank sheet of paper. Yeah. Now, for the very first time on the world, we developed with GE and Andritz a triple regulation Kaplan turbine of 20 megawatt size for marine application. Triple regulation, and that's a first again globally. And again, the application pushed the engineers to come up with answers. And again,
At this point, yeah, I want to interrupt, but so these innovations are very important. So we have, as you know, regular meetings, and once you gave a presentation in our meeting, Miroslav did also. So in these meetings, we talk on predictive maintenance, usage of big data, also variable speed control, and AI technologies. So what do you think about the implementation of these technologies into our daily lives or into our operators' daily lives? So is there any barrier for them, regulatory, technical, or economically, that that prevents them to implement that innovation into their system, their operation? What's your opinion? What's the barrier?
Yeah. I cannot see it being a barrier. I can only see it being positive as long as we know how we are tackling it. And most of the projects that we are looking in the UK and also UK and Europe today that I'm aware of does include AI and in many respects. And since this is the water nexus, I had papers from Lancaster with my PhD students, even for using AI with utilities in the UK at the moment for leakage control, which is a big headache in the UK. I mean, I live in a country that we have probably most of the rain of the whole of Europe, but we do have problems with banning watering the grass on certain times of the year. So water problem is not only in Salzburg, is in the Lake District where I live, 10 minutes from the largest lake, and we still have that problem there as well. And AI will really help us also in the next phase because we can see with climate change, we have sea level rise. And sea level rise is a serious problem where we will need civil engineers to really help us there because we are lacking and we need extra help. And I'm already working on projects in Brazil where it is a serious problem with climate change, the water level going down. They rely on 300 very large hydropower plants there, and most of them now operate with beyond cavitation limits, which means serious, never mind the reduction on power, but serious problems on vibrating and cracking on the civil side of so there are a lot of help we are going to see from AI moving forward.
Thank you. So let's continue with Miroslav. Miroslav, do you have any example of barriers that avoids you to implement your innovative idea in your field?
Well, yeah, but they are okay. So first of all, regarding this natural growth of innovation in this area, you mentioned this monitoring systems that help, and they will grow. Currently, we have systems that monitor certain elements like a generator, a turbine, maybe a hydropower plant, maybe something. And naturally, this will evolve into systems that will monitor more and more the entire grid systems, but not only on a global scale, but on a very minute things. And these digital twins are part of that, and so on. But generally, the main concern that we see is the public awareness and public opinion about the entire thing. And that's, I think, the main problem. We saw last time that we were in Brussels, what happened when these students came and they gave, like, they created videos for the hydropower plant, and we asked them, why did you do it? Do you really believe in this technology? They said, no, we actually are against it. We came just because we got the trip to Brussels. That's it. So that's the main problem. I think that people see this technology as a bad thing, and that then leads to all kinds of barriers that we have. We see now in the car industry that was for decades against electrical cars. Now that this started to be mainstream in China, these Chinese people are inventing things that were thought impossible by people who were like more conservative, and that's what we have, I think, in hydro. We are stopping because public opinion is against it, and you get stopped in a track. It is demotivating for even people who would like to do it, and then that's like a turn down wheel that spins in nothing, and that is, I think, first thing that should be changed, and then things will go up.
Thank you so much. Miroslav, do you have any example of barriers?
Yes, the barriers we can say are, as Miroslav said, the main problem. One of the problems is for sure that hydropower has a not very good public opinion. Reason for this is that, in my opinion, that the hydropower is technology which is known for more than 100 years, and we know all possible problems which hydropower can make. Additionally, the hydropower people, the generations before us, we can say, made also some solutions which were for sure not sustainable in any case, and it was maximizing of the profit. All of this was going on the maximizing of the profit or the maximizing of the energy production. As I said at the beginning, looking just from the technical point of view. Now we must look much more wider, and this makes, in my opinion, the challenges and the restrictions, because such wider look is in most cases resulting in the less production. Less production means less income, and additionally, these additional solutions, we can say, are resulting in the higher construction costs, and this makes our projects not so profitable. And this is, I think, the main challenge what we have with hydropower now, and in the future, what we will have, because we need to make it economically available and economically free, but at the same time, it must be solving the problems of all other nexus, which means also suitable for food production, suitable for ecology, and this is, I think, the main challenge with the hydropower will have. We are still most effective and very good technology compared to all other energy technologies, also compared to the other renewables. But we must know where are our weak points, and we must try to solve these weak points in all of this one.
Thank you. Yeah, George, please.
Just to continue on the point that Miroslav is doing, I agree with everything we said. but really a key part is also funding. Nothing will move without funding. This is why, like in the UK and Lancaster University, we developed a model in a circle where we include all these elements. Yes, we might have a Rolls Royce of a turbine that it's upper 90s% efficient, but environmentally, we might have a problem. Funding might not be available. Local politicians might say no. So whenever we have the funding to progress, and this is the key, we need to have all elements progressing in parallel. So any project will move on as long as the weakest link in that circle is solved, is satisfied. If the local mayor says no, nothing will move in Salzburg. That's it. But if the local mayor wants some money to build a small playground for the local school, it is yes, then the project could be budgeted along those lines. And yes, there are big projects to move on, but we need to address them in a holistic approach. If the World Bank gives the okay, we could build a project that is twice the size of the Three Gorges. We're discussing about it now in Congo, the large Inga project. 22.5 gigawatts is the Three Gorges. The Inga, not the existing ones, the new one, could be double that, 44 gigawatts. And it could happen as long as the weakest link that I'm discussing is satisfied. Probably before any yes comes out of it, we might see several wars in the region till a political situation is the appropriate one, before the World Bank says yes and other elements are satisfied, including environmental implications or anything else that might be the weakest link. Despite the fact we already have 100-year-old references on turbines.
Thank you.
Yeah.
I would like to add one additional thing that I think that goes to our advantage somehow, and it is the disasters. Disasters are actually good for us because they allow people to budge, and they actually lead to people to change their opinions. And what is happening now, we've seen several blackouts in Europe. This hasn't happened for decades, and it is starting to happen now. Now, I asked Daniel, and he kindly provided us here with the map of the Europe, just to give you show what is going on. And like you can imagine an X sign over the Europe, like a cross, where that cross is basically has its legs from Spain to Russia, and from Great Britain down to the Greece.
Cyprus.
Yes, Cyprus. Yeah, Cyprus. And what happened in 2024? We had a blackout and a great wave in Montenegro and Albania, and that caused shortages. And now this year, just a few weeks ago, we had a big blackout in Spain. And you can see that these things are happening on the edges of this electrical grid. So what happened there is that voltage dropped by to 48.8 hertz or something like that, and then everything's all the protections started to drop off the power plants, and these kind of things happen because solar and basically power converted operated machinery is not capable of holding this grid stability. what keeps the grid stability are large generators that have large inertias. Yes, large mass. And you can actually add the mass by using flywheels and so on. You can have turbines weighted additionally. And so these elements allow for a grid to be stable for a few seconds and allow for these disturbances to pass without breaking the entire network. And so we have like 2024, we had like Balkans, that was not important, therefore. Now we have Spain, that's like, the second, but now in a row will be Britain, Norway. Now it will become interesting because these countries have strong opinion from the people. And when these things start to happen, then they will start to investigate what solar can actually do and how can they fix it. And this is basically what I said, the only information that we now have as something that can fix the grid. Batteries cannot do this. And I think that public awareness about this will grow. And then the hydropower plant will not be that boogeyman. It will become interesting option again. Yeah.
Yes, maybe just a short connection to this one, which fully agree. And the mess, we can have the big masses in the grid from a renewable point of view only with the hydropower. Other turbines are with the big mass are nuclear power plants which cannot regulate, or the gas turbines, which we know which problems have had in last years. We had a meeting. Edward was also there on beginning of April in Brussels. It was a hydropower day, and which was discussion about it, and especially discussion about the storage. What comes out is for 100 megawatt hours of the or for 100 megawatt of power, renewable, unpredictable, as I call it, wind and solar power, you need at least 10% additional storage. And as Miroslav said, this storage can be done by batteries as a storage of the energy, but not as a storage which can regulate the grid. For regulating of the grid, we need pump storage. And this is something which is, we can say, really booming in the Europe and also around the world, where I can say my company is working last 15 years, nearly 95% on it. New pump storage in the Alpine regions, new pump storage in the partly the developing world, like Indonesia, Thailand, which is not developing world. Also Israel is making pump storage power plant one after another. The third is in construction. Two are working in last start to work last 5 years, we can say. And this is we can say a renaissance of the hydropower for sure will be in the pump storage.
Thank you. And just to continue on the same subject, I fully agree there. So to let you know what is happening in the UK. We are an island. For years, because we only had a tiny interconnection with France, we relied on pump storage, Festiniog, Dynoric in Wales, and unfortunately we don't have mountains in England, but we have in Wales and also in Scotland. And this is where that's how we tackle the problem whenever we play Liverpool, Manchester City. And we suddenly need extra power. And, discussing with the director of Festiniog Dynoric, he can be on full power on the national grid within 30 seconds, perhaps if he has it idle running within 5 to 10 seconds, so fast. And this is why at the moment, to follow Miro's point on grid, in the UK we are building interconnectors left, right, and center. We are even thinking of interconnecting with Iceland, never mind Norway, Denmark, France, and everything else. While in Europe, you were in the rest of Europe, you were in more comfortable situation. I was in the office of the director of EDF in Paris, and I was saying how lucky you are that you have this interconnectors, because we have a problem and we solve it with pump storage. And he said, yeah, we have, and also in France up to now they had 85% nuclear, and now they're moving down to 40-50% and increase other energies. He says, yeah, and unfortunately, nuclear gives us base load. And I said, how do you balance your grid? He said, whenever we have a Paris Saint-Germain Manchester City game, they have blackouts in Milan. And this is how they solve, because of these interconnectors you have in Europe. This is how, is this correct? In Italy, do they have any blackouts in Milan? A small one, okay. Then it's partly true what they were telling me. And again, I was in Germany, that on that specific day in a central office, they were transferring energy from renewables, from wind, into nuclear France. So the grid, can create magic in the whole of Europe, and pump storage could really balance the grid in the best possible way, I think.
Thank you, George. Before proceeding with the future directions, I want to ask our audience or online if anyone wants to share his or her experience for the innovative technologies we talked on today, and for any other successful stories we want to share. Any online questions, Steven?
Hi, can you hear me?
Yeah, please.
Hi, I'm Emanuele 40. I would like to thank you very much for the presentation. I would like to say that also in Italy in 2008, there was a national blackout, and pump storage hydropower, especially the one in the north, were the one that were used to restart all the system, especially the pump storage in the Aosta Valley. And was a national blackout probably due to the immediate delivered of photovoltaics electricity into the grid.
You said 2008, right?
Yeah.
Thank you for your contribution.
Thank you.
In that event, there was also a problem with the grid in Switzerland that affected the Italian network in the northern part. So it was a combination of factors causing the blackout, not only the injection of extra PV.
Thank you.
Thank you, Joan. Yeah, let me proceed with the future directions. So I want to learn our speaker's opinion on the future directions of the innovations. And we have about 10 minutes.
Okay, the way I see it for future innovations, obviously, for small utilities, inline turbines might be a solution all over Europe, yes, including the UK. But for very large hydro, I'm talking about hydro that will need probably all GE, Alstom, Voith, and Andritz working together, could potentially come from the tidal range projects in the west of England. There, we're talking about big projects, and I'm involved on all of them in the UK. One that is, I can see it from my office, is Morecambe Bay. Morecambe Bay has probably the third largest range in the world after Annapolis and Bristol Channel, and the Morecambe Bay project that I can see probably we have from the largest offshore wind farms there at the moment. This is why UK is #1 on offshore wind in the world. We can generate 4 gigawatts of power now. To do this in a sensible way with, let's say, 9-meter diameter or 8-meter diameter, whatever is the upper limit of manufacturing for Grenoble, Ravensburg, and Voith. It could need collaboration of all 3 of them at the same time, and it could solve problems, including climate change, sea level rise, and also flooding, that we have serious problem with flooding in the UK. So probably, and this is just one project out of many that we could develop there. This is on a very large scale, and it's been discussed, and I hope they're serious, because I keep speaking to I don't know how many MPs at the moment in the House of Parliament in London to take it forward, although I'm a bit reserved, having faced the UK politicians for many, many years now.
So you suggest a collaboration of big manufacturers?
Yeah, it's something that it should happen. They cannot do it themselves if we want to deliver a project like of this size in a reasonable time. And it's not something that has not happened in the past. They worked very, very harmoniously in Brazil, in the Rio de Madeira project, all 3 of them. So there is the protocol of how to work nicely together from the past. So we can renew all that now with this new types of projects, and a lot of people, at least in the UK, we are working very, very hard to develop that, and on top of that, to bring the technology cost down, because we are thinking of climate change as well. I cannot say too much because of confidentiality agreements. Currently, I'm working with a Rolls-Royce idea on how we can use the same machine, that it could be a machine operating almost the same efficiency on turbining and pumping and fish friendly, to ensure that we can address the generation problem, the climate changing problem, and ensure that efficiencies do not go from 90 or mid-90s turbine and drop down to 60s, 80s when we are pumping. And this is what we are developing as we speak in the UK.
Thank you, George. So, Miroslav, what's your opinion on the future advancements?
Well, I will be very technical. Basically, on what I said, I think that systems, monitoring diagnostic systems, will be merging into larger systems, that machine learning algorithms will help in regulating energy flows better than humans can. So that will help. Cost of hydro energy systems should reduce by automation, and the small hydro systems should have reduced construction works to reduce the cost. And in the end, we need to think about how to approach this solar, because I think that we are very I don't know how to say this. very gentlemanlike about that technology. We were fighting against the people who were spitting on hydropower, and we were not addressing issues of solar. I heard recently that the Chinese are using double chips in their solar power converters, especially for United States market. One main chip which passed all regulations and securities, and the secondary which is connected by special SIM card to their satellite grid, and which can basically override the primary chip and cause these power converters to fail, basically causing energy issues. I don't know if this is a conspiracy theory or not, but we should address the thing that we are buying things from China, which is actually cheaper based on their SAP subsidies, and are destroying our own industries. And I think that maybe this, what is happening now with car industries, might trigger the change in people's opinion about what they are implementing.
Thank you. And lastly,
Yes, just for the last what the other speaker said, what we need is a sustainable hydro. What we need is following the as I said, nexus of energy, of water, energy, food ecosystems. We need to develop technologies which will be sustainable. I will say, as I said, these solutions will not be the absolutely technical most optimal solutions. The problem is in financing these solutions. Of course, we cannot put all of this on the cost of the developer of the project, because he is interested in selling energy, and he must bring the money back with selling energy. This means we need another financial resources in the form of European Union and also governments, local governments, which will help us in solving all these challenges. Not saying problems, challenges what we will have with such holistic solutions which will be needed in the future. And this goes from the energy production and goes to the energy storage and goes to the grid regulations. I normally I heard a few years ago in Edinburgh there was a financial discussion about the hydropower session, and there was one paper which said that till 2030 we need to double storage capacity in the Europe. I hope this is too pessimistic solution, that this will not happen, because in other case we will have a lot of blackouts if this is really the solution. But what we need is all types of renewable, sustainable solutions in storage and in the production. Thank you.
Thank you. So I want to thank your participation here and our very expertise speakers. Before ending the session, I want to ask if you have any questions online. Okay then. Thank you again, and it was my pleasure to moderate the session, and hope to see you in our next event. Thank you.